So here we go. First question. Where's my notebook? Oh, God. I left my notebook upstairs. What? No, do me a favor. Well, can you go upstairs in 202 and go up to the teaching station and see if there's a notebook laying around there? It's a notebook. And I'll be getting ready. All right, let me go on into the 9.5 and 9.6. Let me go there since I left my notebook.
Oh, here he comes.
Let me go to 9.5 and 9.6.
Equals negative 3. Yeah. This equals.
Okay, Pendleton, are y'all listening?
Yeah.
Okay, because I don't mind you talking, but good gracious, when I want you to talk, I want you to talk when I ask you a question, okay? All right, so Math 111, where are y'all? There you are. 5.6, now 5.6 and 5.7, the only questions I'm going to ask of you in 5.6 and 5.7 is calculator type questions, all right? But I'm going to show you today what kind of questions I'm going to ask you. So 5.6, I'm sorry, 9.6 and 9.6. Is it 9.5 and 9.6? Okay, 9.5 and 9.6. Because I'm not going to go into a lot of questions about these. Okay, I'm not going to go into a lot. So just pay attention with what I do today, and that will give you a good indicator of what I'm going to do as far as the test goes. So with this being said, let's go ahead and look at trig. Now, that's not it. It's 9.6. Damn it. 9.6 and 9.7. Isn't it?
Yes, sir. Yes, 74.
Is it, look in your notes, I think it's 9.6 and 9.7. Okay, now, when you unroll the, there we go. When you unroll, and I'm going to do this on the whiteboard, just take the unit circle and picture this in your brain.
Which is 0.2.
There's the unit circle.
And then your period is 2 pi over b, so it'd be 6 pi.
Okay, are y'all finished? Okay, are y'all finished? Are y'all finished talking? Okay, thank you. The unit circle, go ahead and label the unit circle as far as somebody needs to turn the sound down. I'm getting a feedback. Turn your sound down, please. Here is 0 degrees. This is pi over 2. And this is pi. And this is 3 pi over 2. And this is 2 pi. Now, if you unroll the unit circle, remember, this is what? 1, 0. Everybody with me? This is 0, 1. This is -1, 0. This is 0, -1. Now remember, this, I'm going to highlight the sign. Did you find it?
There was a blue binder.
Yeah.
But it's not Math 102.
Well, I've only been in one place this morning.
It was next to the computer upstairs.
Was it a...
Look.
No, it's a notebook. It's like a, not a notebook. What do you call it? Spiral?
Yeah, like a spiral notebook.
Yeah.
But like a pad that you flip.
Yeah.
No.
No, that's not.
Or this is traditional.
Get on the front desk and ask them. I don't want to leave the class. If you don't mind, ask them. Tell them I lost my, I misplaced it. It's just notebook paper.
Okay.
And see if I left it down there on the front desk.
Okay.
What happened? I'm sorry, I lost my notebook. Okay, now I want you to highlight the sine and the cosine. The sine, we'll highlight the cosine in blue. There's the cosine. There's the cosine. There's the cosine. There's the cosine. And then back to 1. Everybody with me?
Yeah.
And we'll highlight in yellow the sine. Now, if I unroll, you know how you take and I hate to use this, but I'm trying to think of something. I can't use an orange. Okay, I'm going to use something simple like a Skoll or a Copenhagen can. Okay? The reason I'm using that is I can't think of anything right now. If you take a Skoll or a Copenhagen can and you take the label off and you unroll it, what will you have? You'll have a straight what?
Line.
A straight line. So let's cut this thing right here. Let's cut it right there, and let's unroll it. If we unroll it, we're going to get a number line that starts at what? 0. Okay? And I'm just writing this out for right now. Pi over 2. Nothing?
No, sir.
I know it's here somewhere. Pi over 2. Then what? Pi, and then what? 3 pi over 2, and then what? 2 pi. Now, if I add a y-axis to that at 0, then I go the opposite direction. I'm going to add a y-axis to that. Like that. And what would be in the other direction? Same thing, right? So we would have, and I'm going to put this in red, like this, and I'm just going to put this first one, negative pi over 2. Everybody understand? Okay, Pendleton, y'all understand? This one I want y'all to talk.
Yes.
Okay? Easily? Oconee? Where's Oconee? Don't we have Oconee?
Right here.
Okay, I'm sorry, I got my TV set up differently. What we did, we unrolled this thing like we were talking about Copenhagen. We took the label off the Copenhagen can. So we cut it right here, and that right there is right there, and we unrolled it. Okay. And this is pi over 2. So somebody tell me, and I'm going to take my blue highlighter, and I'm going to use my cosine. Let's do the sine curve first. So what is my sine at 0? I mean at 0 degrees? What is sine at 0 degrees? 0. Thank you for the interaction. What is the sine at pi over 2?
1.
Let's put a 1 right here and a negative 1 right here. All right, what is my sine at pi?
0.
And what is my sine at 3 pi over 2?
Negative 1.
And what is my sine at 2 pi? Now connect those dots. So what is the sine curve? The sine curve is you unrolling that unit circle over and over and over and over and over. That's all it is. Some people go all throughout their math career and don't realize that the sine curve is unwrapping the Now you can go the other way. Okay, negative pi over 2 is going to be what? And you go down, it's going to go down. It's going to follow the same. This is called a what? What's it called? Let me take my highlighter. I'm going to use a different color. Let's use green because it's very important. Somebody tell me what this is called right here. It's called a revolution when you're talking about the circle. Well, what's it called when you talk about the sine and cosine and tangent? What is it called? Starts with a P. P, E, R.
Period.
Period. I was wanting somebody to get it. I thought somebody would get it that, you know, had tricked before. Okay? Okay, I do want to remind people to be courteous. I realize that y'all are on your laptops. I also realize that some of y'all are not looking at what I'm doing. Just want to let everybody know that. Okay, so this is called a period. Now, let me go back. I'm going to go back now. I'm worried about what I did with my daggum. I know that notebook is somewhere in 202. It's got to be. That's the only place I did this. Okay, now I'm going to go back. I'm going to go to another screen here, and we're going to go back to our algebra review. Here's my algebra review. Remember when we did f of x is equal to a times x plus h quantity squared minus plus k? Or I told you to do, you remember your parent graphs? Absolute value. Absolute value of x plus h squared plus k. F of x is equal to a square root of x plus h plus k. Everybody remember these?
Yes.
Somebody tell me what I told you A was. What did A do as far as telling you information about something? What did A tell us? Okay, basically the orientation. That tells us orientation. A tells us orientation. Y'all remember going over this, right? Y'all should. Yeah. Horizontal shift, vertical shift. Yes, no? Pendleton, do y'all remember?
She said yes.
Okay, Oconee, somebody tell me if you don't remember. If it's negative, what does that mean? It's going in the opposite direction. If it's positive, that means pretty much your parent graph. Remember the parent graphs? I gave you about 8 or 10 of them. Okay? What does it tell us if it's between 0 and 1? It's going to be what? Wide. Which means it's going to be stretched along the x-axis and compressed along the what? Y-axis. Y'all remember going over this?
Yeah.
If A is greater than 1, it's going to be what? Narrow, which means it's compressed along the x-axis and stretched along the what?
What?
Okay, are we going to see this in 6.7 and 6.8? Yes. F of x is equal to A times sine of theta plus 5 or whatever. You're going to see it right here. You know what that's called? It's called the amplitude. It's called the amplitude. Amplitude is when it's squished up or what? Spread out. What is this called? That's called the horizontal shift. And here, f of x is equal to a times sine of x plus 3 plus 6. This is called not the horizontal shift, but the what?
A shift.
So is this something that you've seen before? Yes. You've all seen this before. Now you have to apply it to your sine curve and your cosine curve. Now, why do I keep saying sine and cosine? Because that's technically the ones that are most important. Okay? So let's go back to the problem that we were doing. And I'm going to have to depend on the slides today because somewhere between 9 o'clock and 9:05, I lost my notebook. So I'm sorry. Let's go back to here. So let me ask you this. We know this is a sine curve. What if I was to do this? What if I was to say f of x is equal to 2 sine of theta? Well, 2 is greater than what? 1. So that means that I'm going to squish this. I'm going to compress with x-axis, and I'm going to stretch along the what? Y-axis. If I make it 1/2, I'm going to what? I'm going to spread it out along the, and compress along the y. So the same things that I've been teaching you with the parabola, with the square root function, with the parent graphs, I'm doing here. So I want you to add the sine curve, the cosine curve, and the tangent curve to your family of graphs. Just put it on the back. All I care about those 3. You can expand on those as you go into Calc 1 and 2 and all that. Now let's do the cosine. So I'm going to do the cosine in another color. We'll do the cosine in that burnt orange. Okay, so what is the cosine of 0 degrees?
1.
What is the cosine of pi over 2?
0.
And of course you see -1 here and here. And you see that the cosine is kind of like the what? The inverse. Okay? I'm sorry, I missed one of them. And it goes back down. It should go back down to 0. Yeah. There's, at 1, let's see, 2 pi, and then back down to 1 for the next one. Okay? And of course you can add that right there. And then over here, it would be right there. Now, what else do you notice about the sine and the cosine curve based on the unit circle? Can anybody tell me what they see? Has to do with your range.
Cosine.
What's the range of cosine and sine?
1.
1. And? -1. So your range is always going to be on cosine and sine, -1 to what? 1. So this is kind of like an introduction that I do to sine and cosine, because I just tell you, okay, go into sine and cosine. You're not going to bring in that information that I gave you back with the vertical and horizontal shifts. You're just going to look at the calculator. So with that being said, let's go back to the slide. And here we go into, and I have 2 problems on this, and that makes me mad. I don't know what I did with that thing, but I know it's in, I brought it in. I'm one of those persons that when they lose something, it drives them crazy trying to find it. It's driving me crazy wondering where that notebook is. All right, and there it is. Now, this is what you should have in your notebook, in your parent graphs. You should have this And if you want to write the table down, that's fine, but you need to have this in your parent graphs. So write that down, and you go ahead and write negative 2 pi to 2 pi. That is normal. Some people make that the normal period, because that's one rotation to the what? Left, and one rotation to the what? Right. One rotation to the right, and one rotation to the left. And I guarantee you some person, maybe some person in here or whatever, has never realized that the sine and the cosine curve is basically a two-dimensional graph of the what? The unit circle. Now they're probably going to do sine or cosine next. They're showing you here. Same thing. Now, I want you to be able, probably 90% of 9.6 and 9.7, like 80% of your questions will be on the calculator. Now, there may be one or two questions that you have to factor out to find the amplitude, the period, and the phase shift, but you're talking maybe 2 questions. The period is 2 pi, meaning 2 pi in one direction, 2 pi in what? The other direction. One revolution to the right, one revolution to the left. So you have a period to the right and one period to the left. And of course, how do you find that function? Well, you know this is 0, this is pi over 2, this is negative pi over 2, and then you keep, adding. Next. Again, your calculator, was that sine? Cosine. There we go. Here's your second function to put in your parent graph. Again, notice that the range is negative 1 to 1, like we already said. One revolution to the right, one revolution to the left. Okay? Questions, right, complaint. And they're doing it on the calculator there. And there's 2 sine of x. Now, I am not going to do the columns. That's old school. That is what you used to do when you didn't have a calculator. The classes that I took at Clemson and AC, Anderson University, back then it was AC. When I took my classes there, because I couldn't get them at Tri-County, so I took them at Clemson or whatever, you had to do, because they didn't let you use the calculator that much. And now the tables are pretty much obsolete, but you still need to understand what you're doing. Take the sine of x, take 2 cosine of x. The sine of pi over 2, we already talked about that. What's the sine of pi over 2? 1. 1 times 2 is what? 2. Basically, that 2 is the multiplier, which is a. Remember me telling you that this is a? That means orientation. That means it's a multiplier. So I know that this one is going to be what? Squished up, and it's going to change the range from 1 to what?
2.
2. So now you know that this has a direct relation to the range. Because, let me ask you this. Remember me telling you about the balloon? If you mash a balloon from the sides, what does it have to do?
Get taller.
It has to get taller. It has to stretch along the y-axis. If you restrict that balloon and you push, what's going to happen? It's going to bust, right? You can't squeeze a round peg in a square hole or a square peg in a round hole. You can't compress this sine curve and not let the y go what? Up. It can't happen. So the amplitude will, if they call it amplitude yet, they probably will. The amplitude has a direct relation to the range with the cosine and the sine curve. Now, what I would do if I was you, if you have a graphing calculator, change your, I'll show you what you should be able to do. Let me take my, you should be able to take your handy dandy calculator, if I ever find it, and this is what you ought to do. Y is equal, and change the first one to a parent graph. Change it to the dashed line. There we go. And I'm going to call it sine of x. And I'm just going to delete, clear, delete. Okay, just wait a minute. There we go. Sine of x, close parentheses, and then go below there and do 2 sine of x. And then I'm going to do a third one, and I'm kind of getting the cart before the horse here. It's your parents' fault if you don't understand what I just said. And I'm going to say parentheses 1 divided by 2, 1 divided by 2, close parentheses, sine of x. And I'm going to make that a dark line. Everybody with me? So, hit graph. There is my, and there's the second one. And then the third one's going to be stretched out. Okay, now of course I'm going to pull that up. Zoom, standard. Okay, zoom, fit. Play with it a little bit. Zoom, what is fit? Is zoom fit is 0. I was going to see if I could get it to just pull up. No, it's not going to. I'm going to have to pull up the right side. There we go. All right, there's that one. There's that one. And there is that one. So what's happening? So the first one is at 1 to 1. The second one is at 2 to -2. And what's the range of the dark line? -1/2 to what? 1/2. The same thing that we talked about with the vertical and horizontal shifts, the parabola being squeezed, being pulled, same thing. Now, I hate to spend so much time on it, but hopefully you should have made that transition. If not, then we'll just write it up as a disappointment. There we go. Here's the amplitude. Now they're finally calling it amplitude. Is half the difference between the maximum and minimum values. It describes the height of the line, blah, 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 blah. Let me just go to the next one. The graph of y is equal to a sine of x, or y is equal to a cosine of x, with a is not equal to 0, will have the same shape as y is equal to sine of x, or y is equal to cosine, blah, 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 blah. Sine of 2x, the amplitude is going to be 2, the coefficient of 2. So the period is equal to 2 pi over 2. All right? Now, let's go ahead and say that. All right? If we want to find the period, write this down. The period is always going to be equal to 2 pi over b. 2 pi over b. B is your coefficient of sine of 2x. Now, it's also now 2, now a while ago, this was 2. Is that B or A? That's A. We're talking about B now. Okay? B is going to be in front of your X. So if you want to find the period is going to be 2 pi over 2, which is equal to what? Pi. So now we're only going from 0 to what? 180. Okay, so if they ask, now what will they ask in the question? They'll just ask for the period. They might ask for the amplitude, they might ask for the period. That's the two questions that I'm going to ask you that are non-calculator related. Got me? Those are the two questions. So you can hear me now? Miss, okay, but she's muted. Why is she muted? You don't have to mute yourself unless you got a
It was echoing for some reason.
It's what?
It's echoing.
Okay, I'll turn mine down. Hold on. Okay, I'll turn mine down a little
but I
bit.
couldn't get them.
Okay. Well, you were asking questions about this section. Is it making a little bit more sense now?
It was the circle unwrapped that made all the difference.
Good. How about you, Pendleton? Does it make a little bit more sense? And Oconee, easily?
Yes.
Good. How about y'all? Y'all just say it, man. Okay, so now the only thing left is the phase shift, and that's like the horizontal shift. So the graph completes the period of the interval to 0 to pi. The other interval would be 0 to negative pi. I'm not going to ask a lot of this stuff, so that's why I'm skipping through it. Plot the points from the table, this case, and the difference, the graph shrunk because instead of going to 2 pi, I'm only going to go to what? Oh, well. I'm only going to go to pi. You see what I'm saying? And negative pi. So my period at the beginning was from negative 2 pi to 2 pi. Now, with this last example, maybe from here to here when we just got a period of pi. So when you're thinking of a period, you're thinking of one revolution to the right, one revolution to the left, and the period is always going to be equal to 2 pi over b, and that b is going to be in front of the x. And the amplitude is always going to be equal to a. Of course, if you change all these things in your calculator, you'll see it. You need to use the dashed line, the solid line, and the dark line because you can see the best differences there. And there we go. Okay, will resemble that, blah, blah, blah. They're just telling you with sine and cosine, that's the period. Okay, this one, you know that A is equal to 1. Therefore, it's a parent graph. Meaning that it looks like what? It looks like the graph that you got in your notebook. Okay? Now, the 2/3, that tells you you've got a period that you need to find out. If it's 1, let me ask you a question. If that's a 1, then it's 2 pi over 1, which is 2 pi. That's the standard period. But if it's not, then you take 2/3 and you divide by what? 2 pi divided by 2/3. 2 pi divided by 2/3, which means you multiply 2 pi by what? 3 over 2, which means that those two cancel out, and you're left with what? 3 pi. So now you have what? 1.5 revolutions to the right and 1.5 revolutions to the left, because what's 2 pi plus pi? 3 pi. So that means 1.5 revolutions, where 4 pi would be 2 revolutions to the right, 2 revolutions to the left. I hate to be repetitive, but I'm trying to drill something in your head here. So that would be 3 pi. Okay? And this is how you do, now how do you do that? You just divide by 3 pi, you divide 3 pi by 4, and that's what you get. 3 pi by 4, and then you divide by 4, divide that by 4, divide that by 4, and you get those 4. Okay? And there it is. And you see what they're doing right here. You could do the table if you wanted to, or you could just do it on your calculator. And if you did it on the calculator, when you take that 2/3, the 2/3 is going to be calculated in the calculator, and then it's going to be go to the as 0 to 3 pi. It's going to know that when it counts it, when it does the conversion. And there is your 1.5 what? Rotations. So you can see that here is 0 to pi, and then it does 1 other revolution, 1/2 of a revolution. Again, this is calculator. This is old school. If you want to do old school, you can do it, because you know that here are your x's, and then you just plug in. You just think of going around that's where the zeros come from, 0 and 1. That's where that comes from, and you just multiply that by 2/3 or divide by 3, whatever. Again, you don't have to do that. That's old school. Okay, let me move on. I want to see, okay, here's a prime example. We know that the parent graph, okay, we know that the parent graph of sine looks like this. And this is a test question, not all this down here, but this right here is a test question. This right here, that's your test question. I want you to be able to visualize this. This is what I want you to be able to see. Let me do this in black. My parent graph, we know the parent graph looks like this, right? Everybody with me? Okay. Now, you could take that on the other side too. I'm just focusing on this side, okay? We know that this, what does that tell us?
Opposite.
That tells us that it's going in the opposite direction. Everybody got that?
Mm-hmm.
And does that come from this unit, or does that come from review unit and last unit? That comes from previous units. That's nothing new. What does this 2 tell us? That tells us that our range is not going to be 1 now, but it's going to be what?
2.
2. So now our graph is going to look like that. Y'all see where I'm going with this? You should be able to see this from what we've done with the parabolas and all that. And now the 3, of course, that's going to change. 2 pi divided by 3, right? Multiplied by 1 over 3 is 2 pi over what? And that's your period. That's the kind of stuff I want you to be able to tell me. We haven't got to phase shift yet. That's probably going to be the next couple of slides. Phase shift. Now, as far as graphing it, I want you to do it on a calculator.
I can't figure that out either.
Because this is what you used to do a long time ago. And I'm not really, you can take these charts and you can deduce what to do there, okay? And I have an example in my notebook, which I can't find right now, but I'll do that with you Tuesday, because that's when we're going over homework questions and pre-test, okay? So, let me move to the next one. I want to get phase shift in. And that's what it looks like. I guess that's the one we just did. And we notice that it's going in the opposite direction like we said. And here is this should be the phase shift. Yes. Okay, so there is the phase shift. And notice the phase shift is where we used to see the old horizontal what? Horizontal shift. Remember? Plus H means left. Minus H means what? Right. Is that going to happen here? Yes. Same thing you've been taught. I want to show. I want to go to an actual example. There we go. So here, the phase shift is not going to be 1 to the what? Well, I mean, it's going to be pi over 3 to the what? To the right. Now again, all I want you to be able to do is pull out the phase shift. Now, in order for all this to work, what is this coefficient right here?
Oh, 1.
Is that detrimental to you finding the phase shift? Yes or no?
No.
Yes.
Yes. If that's a 2/3, you're going to have to factor out a 2/3. If it's a 3/4, you're going to have to factor out a 3/4. That means that this number is not going to be pi over 3. It's going to be another number. You got to factor out, you got to make that coefficient of that x equal to 1. So if it's a negative, you got to factor out a negative. If it's a 4, you got to factor out a 4. If it's a 2/3, you got to factor out a 2/3, which they will probably give us one here in just a minute. And there it is. How do you find the interval? Well, you just put x minus 2/3. You take this, and this is old school. You take x minus 2/3, and you put it in the middle. I did all this on my example. So x minus pi over 3 less than what? 0 and what? 2 pi. How do you get rid of negative pi over 3? You add pi over 3. Add it on one side, add it on the other. So 2 pi plus 1 plus pi over 3. Well, we got to change this to 3. That's going to be 6 pi. So what's 6 plus 1 pi? So that's going to be 7 pi over 3. And that's going to be x. And that's going to be pi over 3. So your new interval is pi over 3. I forgot equals. You got to touch. It is 7 pi over 3. Now, if you were doing it old school, you would use, and divide that by 4, you would use those right there, but you don't have to worry about that because now you just do it on your calculator. But do I want you to algebraically tell me what the phase shift is? Yes. 2 questions. A, I want you to find A. I want you to tell me what A does. I want you to tell me what the period is. and I want you to tell me what the phase shift is. And I hope they're going to give us a problem here that will pretty much do all three. There. Now that's what the phase shift is. Pi over 3 to the what? To the right. Can y'all not say that that is a horizontal shift? Is this a horizontal shift? Yes. Same thing as we did with the quadratics. So just add 2 pi, add pi over 3. 2 pi over 1 plus pi over 3. That's supposed to be a 3, that's 6. So that's going to be 7 pi over 3. Now, the reason I'm not showing you cosine is it works the same with cosine. You're going to figure out that 80% of your questions are going to come from sine and cosine, whether it be in trig or whether it be in calculus, because they're the dominant two that you use on anything pretty much. The second would be tangent, and the rest of them you really don't use that much. I was hopefully they're going to, there's the graph. That's what you'll be on a test. That's what I would ask you on a test. And of course, anything outside of this, so if I like, okay, here, there is the vertical what? What have we not talked about? We've talked about amplitude, we've talked about period, we talked about horizontal shift. So what do you think the number sitting out by itself would be? The vertical shift. Questions, right, complaint. So if you go through this one, you're going to have there we go. You're going to have a vertical shift of 3 up. So instead of, let's see, 2 is our range, right? That's our range. I'm about ready to quit. That's our range. So we've got to add 3 to our range. And if we add 3 to the range, what do we get? We get 5. And now the range is from 1 to 5. And the way you get that is right here. Now, of course, that's old school. So you would just look at it on the calculator. That's still not the one I want. I'm wanting you to, I'm looking for it. Hold on. There we go. This is a test question. Now, there's 2 questions I would ask you on this. One is to graph it. That's easy. You can do that on a calculator. The other is I want you to find, and first of all, I'm going to turn it around because you're used to seeing this. Y is equal to A times X plus H, blah, 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 plus K, right? That's what you're used to seeing. So let's turn it around. Y is equal to 2 sine of 4x plus pi minus 1. Now, what is our A? I'm just going to highlight a couple of things. Y'all ever have one of these days where just nothing works right? Y is equal to 2 4x plus pi negative 1. Now I'm going to try this again. All right, this right here, I had it written down a while ago. Try it again. Y is equal to A times X plus H plus K. course, that could be anything. It could be a square or a cube, or I'm not worried about the exponent. All right, let me go back to all right, this is right there. Trying to make a little bit of association here for those that are still kind of groggy on this. H is pretty much right there, but this is not what? That's not 1, so we're not ready for that yet. And then this is your vertical what? Shift. So what's the only thing we have to do to get the algebraic stuff that I want you to get here? What do I have to do? I've got to factor out a 4. So y is equal to 2 times the sine of 4 x plus pi over 4 minus 1. Now I have, and let's write down what we have. We've got a 2, a positive 2, which means normal parent graph. And what does the 2 mean? It means it's going to be compressed along the what? The x-axis, and stretched along the what? Y-axis. It also tells me that the range is going to be -2 to what?
2.
-2 to 2. Now that's at the original, okay? But we've got a vertical shift here, so that's going to change it. But I don't care about you being able to graph it. I want you to just tell me what you see here, right? We know that this means left a phase shift. Make sure you use phase shift, because if you say horizontal shift, some teacher may go, well, that's not the shift. Okay, left, how many places? Pi over 4. So that's your phase shift. And then what does the 1 tell us? That means a vertical shift of 1 what? Down. Okay, now if I ask you, let's say if I ask you 4 questions on the test. 2 will be graphing sine and cosine, and 2 will be something like this. That's all I'm going to ask you out of 9.7 and 9.8 and 9.6, now whatever they are. Andy, which one is it? 9.6. 9.6 and 9.7?
Yeah.
Yes.
Okay, that's all I'm going to ask you. Now make sure you can do it with both, cosine and sine. And you're going to lean about 80% on the calculator and about 20% on this. This is algebra. Because all you're doing is putting the trigonometric function in the form of an algebraic equation. That's what you're doing. Does this help? I know, Mandy, you've done some of these. Does this help?
Yeah, that helps.
Who else has done some of 9.6 and 7? Does this help?
Yes, sir.
Yes, sir.
Okay. All right. I'm going to let y'all go because I don't know where my notebook is. This is what I want everybody to do for homework. I want y'all to get the homework done. I want you to send in the rest of your questions. Now, 10.1 and 10.3, y'all should have done. I've just about done every one of those problems, except for a couple that don't. There's a couple of those questions that I really don't. I will try to do this weekend. There's a couple that I don't think, or I think they are new questions because they don't have any explanation to them. So I think they were just put in this semester, and I will try to do those for you. There's about 3 that I haven't done yet. The rest of 10.1 through 10.3, I've done. Okay? Now, today, you should be able to start on 9.6 and 9.7 as far as graphing and as far as understanding what these shifts and these amplitudes are. You should understand what you're doing now. Does anybody have any questions? All right, y'all get out of here and have a good weekend. I'll see y'all Tuesday, but be prepared for a test start.